Welcome back. Let's see what more can we do with the TurtleSim. We run the TurtleSim again, and we have already seen about the twist messages in the previous video. So what we need to do is that see more details about this twist message, and to see that we can do ROS message show geometry underscore message dot twist, which we did in the previous video. And if you see that it has both the linear and the angular velocity given for the geometry messages. Okay, now that we have seen some details over the turtle sim, let's try to move it using this twist message. Now what we need to do, we need to publish to the ROS topic and give the parameters which are needed, something like this. We can give ROS topic publish tartan1 cmd velocity, and then refer the geometry message under twist and give the xyz coordinates which is needed. So if you give it, and you can see that the turtle moves. Okay, you can also change the values, like this was 3.8 and I changed it to 1.5 1.8, which is the z value. And as you can see, the angle in which the turtle sim moves will change. Okay, now that we have run our ROS turtle by giving the physical coordinates using that twist message, let's see how we can control it through the keyboard. So you can just do ROS learn and then followed by turtle sim, and then you need to call turtle teleop. I recall I talked about teleop in the previous video, and you can see that it is telling us to use the arrow key, and if I use the arrow key, the turtle sim moves. Okay, you can also see the RQT graph because opening so many terminals can make it confusing. So you can see the RQT graph, and you can just do ROS run RQT underscore graph, and here the node name and the package name is the same, so we'll just repeat rqt underscore graph. And if you do it, you would see that the ROS rqt graph will pop up, and it's here. And as you can see that we have the teleop running, and it is with the CMD velocity, and it is controlling the turtle sim. So hope this was helpful, and I'll catch up with you in the next video.